Hi folks, this is a solution to number 20A on page 558. So here they want us to find the angle between this given line and this given plane. Okay, so let's draw a picture to see what that would look like. So here, let's let this represent the plane, and you've got some line that intersects the plane, okay, at this point, and we want to find the angle between them. Okay, so what we're looking for is this angle, which we call theta. Okay, but if we look at what information we're given when we have the vector equation of a line, well, we know we've got a direction vector 2, -1, 2, which helps us define the direction of this line. Okay, but in terms of the plane, we're given this normal vector to the plane. Okay, so here we see that if I take this direction vector and I place it to the to the tail of the normal vector, well, I can find this angle between the normal vector and the line. Say we call that phi. And here we realize that because this is a 90-degree angle, this is just going to be complementary to the angle we're looking for, theta. Okay, so we can use the dot product to determine the angle between the normal vector and the line, and then the angle that we're looking for between the line and the plane will just be 90 minus that. Okay, so let's start by finding this angle phi. So use a dot product. So we take the dot product of the direction vector of the line, 2, -1, 2, with the normal vector to the plane, which is just 1, 2, 1. Okay, so here we're going to, on the left side, we're going to use the algebraic definition. On the right side, we're going to use the geometric definition, which is just the magnitude of the first vector. So 2 squared plus 2 squared plus 1. So that's 4 plus 4 plus 1 is 9. And then here, times the magnitude of the second vector, 1 plus 4 plus 1 is 6, times cosine of the angle between them. And actually what we're finding here is the angle phi. Okay, so phi is just going to be equal to cos inverse of, so let's find this dot product. So 2 minus 2 is 0, plus 2 is 2, over square root of 9 is just 3, times square root of 6. Okay, so let's calculate that here. So we've got inverse cosine of 2 divided by 3 times square root of 6. Okay, and that gives us 74.2 degrees. Okay, but remember, what we just found was the angle between the normal vector and the line. What we want is between the line and the plane, so that's just going to be complementary. So 90 minus 74.2, and so that looks like it's going to be, to 75 is 15, so about 15.8 degrees. Okay, so if we just recap this problem, first of all, we're looking for an angle. Okay, and a good way to find angles is to find angles between vectors, in which case you can use a dot product, and the vectors that we were able to use were the ones that come out of the equations that are given. So the direction vector of the line and the normal vector of the plane. But of course we realize that that angle doesn't represent what we're looking for, but the complementary angle to the one we're looking for, which was theta here. Okay, that's it for this one.